Hi, this is Lester Martin from Hortonworks University, and I'll be presenting another demonstration in our Hadoop's Essential course. As mentioned on the other demonstration videos, we're maintaining some notes about each of these demonstrations on this GitHub project called Essentials under the project, the account Hortonworks University. And right now we'll focus on one called Data Manipulation with Hive. The primary goals here are just to create and load some Hive tables and then perform some SQL queries against those and potentially maybe create some additional tables based on results. And the only thing you have to have done before this is one of the prior demonstrations to get some, there's a couple files that we'll need to use during the day. So why don't we go take a look at those files. Here I am logged into Embari as Maria Dev. So I'm going to go look in the HDFS Embari view, file view, and I'm going to look for Maria's home directory. That should be under user, Maria Dev. And then we put those files in a folder called geolocation, and there they are, two CSV files, trucks and geolocation themselves. So we have the data, that's good news. So let's take a moment and navigate over to the Hive Embari view and just give you a quick tour of this tool. Across the top we have pretty much, when we're in the query, here is a major tab. We're in this editor mode. We have some saved queries, history, user-defined functions, some additional functionality such as upload table. We have on the left our database explorer. This is pretty consistent with a lot of database tools. Show me the different databases, and then for each one of those databases show me a particular set of tables, including things like searching. I know in the XA demo course, there's the customer details. Toggle back to default. Refresh is just a way to kind of see what's going on. We'll be focusing on the default database, just a couple tables there, sample 7 and 8. And then once we start executing and utilizing queries, we have some additional features here for messages, details about test jobs. We'll look at the visual explain a little bit here. Some other visualization and settings that we can set, such as specific properties that you like to have for your Hive execution. So with that said, why don't we take a few moments and just go ahead, and if you'd like, I'll give you a URL for the Hive wiki to kind of run through the DDL that exists, all the details. But what should come to mind as I paste this in here, especially if I kind of put a character turn here and say this is what I call the above the line DDL comments, and these are the below the line DDL comments. Go ahead and kick that off while I'm talking here. The create table should be things you understand well, just from your normal database world, but Hadoop, being able to store any kind of data, etc. The below the line information is really focused on telling you where the data is stored and what kind of data format it is. So we'll just take a moment now that it finished and did a refresh up here. See if I caught it in time. Yep, there's geolocation stage that we just created. And let's go ahead and quickly, I think there's a second table, that we want to create. So let's just steal that DDL. And we'll just overwrite what we have there in the editor. And we'll kick that off. And while that's running, what's really happening here with Hive, these Hive tables themselves ultimately are, setting up, if not declared where they'll be, they're actually setting up a particular location in HDFS that we can go find that and see that information. We'll take a second and just run over there. So we'll go to Hive, the HDFS file viewer, and that default is /apps, Hive, and warehouse. And for our case, since we're not in a default data, we're in the default database, our tables will be just right here. So there's geolocation stage. Just want to point out this is an empty folder, so that's what got set up here, as well as the truck staging. So those create tables created this folder structure where they expected to be. But let's run back over to Hive and see what else we can do with that. Surely that tells us here. Let me just click this on the side here. That told us definitely that there was no information there. But we can also just verify that from a SQL statement. So select all from trucks stage is our first table there. Just a quick execute, make sure that's reporting no results at the bottom here. And There we go, just a bunch of headers, as you see there at the bottom. And the other table, I believe, is called geolocation stage. Let me kick that off as well. Exactly, so no results there, as we were expecting. But there's also other normal commands you might be used to, in your databases. I just want to make sure you know those exist out here. Show tables. There's the tables that exist. That's the same list that you see over here. The normal concepts like describe exist. So how about we describe the geolocation stage table? And describe is going to do what? It's going to tell us names of columns, data types, that kind of stuff. Fair enough. That's what we just created. And another interesting one, since we're a little different in Hive, is the ability to say, I just want to see I want to see what it takes to what it took to create that thing. So we have a show create table, and the table name will actually give us at the bottom here the actual breakdown that we just saw there. What would it take to build that out? And in fact, if you'll remember, we had a fewer lines in this on the other side, which really meant we were picking up some defaults we didn't specifically call out. So that's a very, very nice feature. All right, so now what we'll do is, now that we have some tables, let's go ahead and load those information, load some information into them. So this quick graphic shows that we have these two tables, geolocation stage, truck stage, and we're going to do these kinds of operations, a very classic operations where we move data in kind of behind the scenes into those folders. We use maybe a front door command like load, and you'll see that. And then a little bit, and just after that, we'll talk about some other things like a create table as select. So let's focus on that move table first. And as my notes say here, we're going to go take the geolocation CSV file, and we're going to put it into apps Hive warehouse geolocation stage. So let's see how that works. So I'm going to navigate again back to the file viewer and back to Maria's home directory. And under geolocation, I think we were talking about the geolocation state. So we have a nice little kind of shortcut here. We have this move operation, so we'll say move, and then we want to put that in apps Hive warehouse, apps Hive warehouse, and then the name of our table, which happened to be geolocation stage. And again, I think we talked about this in the earlier Embari overview doc and ingestion demo as well. So we can just paste that into there. So boom, geolocations CSV is in that folder that we expected there. And if that's true, we should be able to go over to HDFS and actually see that information loaded. Oops, I'm sorry, over to Hive. So let's hop over there. And this time what I'm going to do is, instead of doing a select statement from line, I'll just tap this nice icon that says load me some sample data, builds us a pre-built, whoops, I'm sorry, stop the execution. It actually loads it, builds the query, and starts executing the query for us. So I actually slowed it down by doing that. And then there's some of the results, 100 rows of results you see across the bottom here with the columns we're talking about in the data itself. So that was our kind of side door, backdoor loading. Put the information where Hive expects that information to be, and that is a very classical way of getting data into a Hive table. Another model would be to use a load command. So I'm just going to steal this so I don't have to type it. And this model says that we want to very specifically go fetch the information in a particular folder. And I'm going to look older versions. Let me put up that. And go find that information off HDFS and load this particular table with that data. Now, what's going to happen in load is, in addition to, did I kick it off or not? Yeah, I believe so. So let's find out if it did. I guess that's an easy way to do it. So there's our truck stage that we've been talking about. And I guess we just see if the data made it, then I can explain it a little better. So how about we select star from trucks stage, and we'll also limit to 10 or so. And kick that off. Make sure the data actually got loaded like I thought it did. What I was trying to say about load is it actually moves that information from the location that it's at on HDFS and places it, does an actual move operation, and puts it under Apps Hive Warehouse, just like we did a minute ago manually. But that's it. Let's just go take a look. So the data is really there as we expected, and I just want to quick verify that that also made it. So back to HDFS files and look under Apps Hive Warehouse. The truck stage was the one we did this time. There's the trucks data. But just as much, I want to make sure we get that load operation physically move that data. So it will not be under Maria's directory anymore. So as expected, this is empty. We moved one manually. Just via move, we used a load command that actually scooped that up and slid it over there and took care of that for us. So ultimately the same, we had the same result on two different paths. So go back over into the Hive view itself. And I'll take a moment and say that, well, I guess we'll show one other model, the CTAS model, the create table as insert operation. So let me just snag this for us here. We'll paste it and I'll tell you what it's doing. So a CTAS, create table as a select, lets you do a definition about a create table, but instead of declaring the metadata and those kind of things, you simply say as, and then you build a select statement. It could be a complicated select statement or a simple one. You like you see here, and in fact we'll run that and load that information from the SQL statement up into the table, so the data plus the metadata. And now that it's finished, well, let's just simply make sure we can do a select statement. So why don't we select all? The new table is called just geolocation itself. We'll do a limit 100 as well. And kick it off and see that run. And again, the intention here is it's just the same data that we had in the staging table, kind of like you see here. We were building a staging table that was ultimately backed by CSVs, and then we built more of an optimized table built on the ORC file format that we'll be talking about in the larger class itself, not as much in the demonstrations. So we have the create table as done. And I guess I want to do a describe formatted geolocation. Do that real quick. Describe formatted geolocation. So I want to look at that table. We did a describe earlier, but we didn't do a describe formatted. And describe formatted is going to give us a little more details about the metadata, and instead of just the column names like we saw earlier. It's going to give us some what we call detail information, when it was touched, who owns it, those type things. And then in our case, we're kind of just alluding to the ORC file format. So you see this definition that we use our serializer, deserializer libraries, our surdays are using ORC, inputs, outputs, all etc. are based on the ORC file format. And I'll go ahead and paste one more. I think I said it just a moment ago. The good news is that these tables don't have to only be a simple statement, simple select statement, so we can make much more rich and complicated statements here. As well, the table definition and any kind of properties, any of the above the line kind of properties we do in a normal table execution are just as valid here as well. So that's finished, and we'll just verify real quick on the left. As we refresh, we hit default, and there we go. We see our new table trucks right there. In fact, we can just kick off, like I said, click that, does a quick execute and a run, and there are our results across the bottom. So back on the GitHub markdown page, I mentioned there are some other links and other details to think about. I'd link to the fact that there is a rich set of insert into kind of statements that Hive has available. And then there's definitely other operations along that line of insert. Since Hive 14, we have some more CRUD, create, retrieve, update, delete style, normal sounding SQL statements, insert, update, delete operations. There are some caveats for those operations. Definitely take a look at the DML wiki page there and learn about that. And then, of course, there are much more programmatic ways, and from custom apps you write in MapReduce, Spark, Pig, etc., as well as leveraging the frameworks such as Scoop and Flume that actually can drop things directly into Hive. So that said, we have some number of tables, and why don't we take a little time and actually run a few queries. So we have some information if we that we've loaded to this point, and if we want to generate a quick query to find out gas mileage, we can definitely do that. So we're going to build a truck mileage table. We're actually doing that CTAS that we talked about before. So we actually are running a query below, and based on the results of those query, on that query, we'll build an actual table to store the results, and so we'll have those in a much faster mode when we need them later. So now that finished, why don't we take a moment, and I'm curious as much as anything else is to how many results that gave us. So we created a table truck mileage, so why don't we do a select count on truck mileage. And see how many records that table itself has available to us. And the result says about 5,400. So that's good news, because we really can consume something like that in maybe another tool. Maybe there are some times when we have got a smaller set of information available to us, and we might want to retrieve that information somewhere else. So what I'm going to do, I ran the full query, select everybody, and I'm going to just save some results. You can put them in HDFS, but I'm going to bring them down as a CSV file locally. We'll call it truck sample. Sounds good. And this is actually going to just drop locally a CSV file on my hard drive here, which you can see right here. And I'll just open that up with a familiar tool like Excel to take a peek at that. And again, I'm not going to focus too much on this, trucks, mileages, gas, that kind of stuff. There's the mileage that we had done there. Just want to make the point that you can get information in and out relatively easy to another tool. Get some of that stuff out of the way. And if we wanted to run some other queries, we can definitely do that. Let me see here. And this time I'm going to try to use a concept I believe called content assist. So you can just use things like control and space to help you out with some commands. So select, and then unfortunately I need to know the table, so I'm looking for the table we just built, which was called truck mileage. Yep, there we go. So, and I needed to know that truck mileage, so kind of a combination of the two. Up, one, down. I want the truck ID, as I see on the left over there, truck ID. I also want a function like, there it is, average. So an average the mile per gallon. I'll just call it average MPG. There's simple words like from, of course. So from the table truck mileage. And then we'll just do what's it called? Group. There it is. Group by. And let's group it by the truck ID and kick that off. And the results are back. Now, I did hit pause when I kicked that off, and it did take it took longer than a minute on this really small sandbox pseudo cluster environment. But it is possible that a query that you run could take some time. So definitely some things you want to consider doing is for sure, let's save something like this. Why don't we call this what do we call this here? Truck average mile per gallon. So we'll call it average MPG as a query, average MPG. Should you need to come back and find this, so we have a saved query across the top there, and we'll use that again in a minute. But when you have a situation where things run longer than you anticipate them or you would like them to be, I just want to take you a moment to make sure, especially for those that maybe have seen some of the more advanced Hive performance tuning and those type of operations, they build around some of the basic things such as explain plans and the directed acyclic graph, the DAG. And so we have that built in here. So I hit an execute. This is just a classic, give me an execute on the, I'm sorry, I hit execute instead of explain. So I'll hit that off. Explain instead of execute. It just reran the query that it already did. And explains are going to give us the details that, again, are a little outside the scope of this demonstration, but I just want to make sure you know that these kinds of information is available. A textual explain plan. I believe we have a visual, if I can get my mouse to highlight those words, there you go, visual explain plan as well. I can pop up here in this window. Again, we're not going to dissect this right now, I just want to make sure you see that. But we also have the ability to look at the another view called the TES Bari view out there. And from here also see the DAG details about that specific query. So I'll select on that particular query. You can download a bucket of bits and configuration and runtime details. We got some other operations here, a lot of detailed information to help you make decisions going forward. And then as well, much of a graphical view, and this actually fits in quite well with what you saw just a few moments ago, with a variety of options here as well. So again, we're not going to focus on using that data right now. I just want to make sure you understood that information is available. So one consequence by leaving and changing these views is that you kind of lose everything in the Hive view. So that's why we did take a moment and save this average miles per gallon that we could run. And since it took a little time, as we talked about, to run last time, why don't we save that information for later, for subsequent demonstration as a table. So we'll call it the average mileage. We'll store it as an ORC file, and it'll be the result of that SQL statement. And we'll let that run in the background there for us. And the main thing to consider is, we have that information that's available for us. And as soon as it's run, I'll just take another quick select against it to make sure the data is loaded, and we'll wrap this demo up. And it has finished there. Just verify it with a quick refresh. On the left, we're looking for average mileage. There we go. We'll do a run, making sure we have some data loaded in that, and we sure do. So that's it for this demo here. There'll be a few more to go, and we hope you've enjoyed the series, and we'll talk to you very soon.